Hi, we've got a quick review video today. This is an item which was sent to me by the seller DROK on Amazon, and he's the seller of the DROK branded items, and what he sent to me is a USB charge adapter. So the idea is that you plug this into your computer or phone charger, and then you plug your phone or tablet or whatever into this end of the charge adapter, and on the display it will read the voltage on the USB port and then display the current being drawn, the power being drawn, and also show the accumulated energy that's been drawn in milliamp hours. So we'll just have a quick look on the listing on Amazon. So here we have the listing on Amazon, and you can see it's priced at £11. You can also buy it in a version which is attached to a cable, and it has a couple of different connectors on the end of that. And the specifications are it can read from 0 to 30 watts, current from 0 to 3 amps, and voltage from 3.5 to 13 volts. And they've called it a mini USB current voltage charger detector. And it has no LED screen on the front of it, so it looks like this when it's turned on. It has a button on the back of it which allows you to rotate the screen depending on which side of the device you're looking at it from. And then it just has an alert if the voltage goes above 5.3 or less than 4.7 volts, and then the OLED display is just a blue display. If we look down at the specifications, you can see the weight is 0.009 kilograms, the font color is blue on the OLED, and the dimensions are 43 by 20 by 10 millimeters. And then it's got the voltage measurement range, which is 3.5 to 9.99 volts here. It says 13 up at the top of the listing, so I think they made an error here. And then the voltage accuracy plus or minus 0.3% plus 1 words. I'm assuming that's an error. That's probably 1 digit rather than 1 word. Otherwise it would just be completely inaccurate. And then the current measurement range 0 to 3 amps with a accuracy of plus or minus 0.5% plus 2, and then the power measurement range from 0 to 30 watts, and it can also read battery capacity drawn from a mobile charger bank from 0 to 99,999 milliamp hours. And it says it's ideal for troubleshooting and checking the performance of USB power sources. So you may have come across plugging in your phone to various different chargers and the phone complaining or it just charging generally quite slowly. So I think they're targeting this at people who want to see if their phone and tablets are charging at the appropriate current. And then it also supports Quick Charge 2.0 technology, which actually charges your device at higher voltages than the standard 5 volts from the USB power supply. So we'll just have a look at the actual device and turn it on and see how it works. The other end of this extension lead is plugged into my HTC charger for my phone, so we should just be able to plug the device into the extension cable. And you can see you get a little splash screen to start with, and then on the display we've got the voltage of the USB port, the power and current being drawn from this end of the device, which at the moment is 0, and then the accumulated charge which has been drawn from the USB port. On the rear of the device is just the tactile switch, so if you press that switch it resets the device and puts the display upside down, and if you press it again it resets it and you see it from this way up again. And I think that's the only thing that that button does, so there's not really any instructions with the device, but I don't think it has any extra features, so that button on the reverse is just for reversing the display. And then if we plug in my phone, you can see the voltage drops slightly because it's on the end of a bit of cable, and then it's drawing about 0.7 amps and 3.99 watts, and then you should start to see the charge accumulating in milliamp hours. So this is the charger that's designed for this phone, and it seems to be charging at about 0.83 amps. I also have one of these battery bank devices, so this has got something like a 20 amp hour battery in it, or a set of lithium batteries, and we can see how that works. So if we plug that into this device, it's actually allowing the mobile phone to charge at a higher rate, so this is at 0.97 amps. The voltage is fairly stable at 4.97 volts, and the power being drawn is 4.82 watts. And again, you can see the charge being accumulated here. And I don't know if the other port on this device will do anything different. So if we plug it into here instead, no, it's the same, so still drawing 0.98 amps. Now I've got one of these multi-chargers which has 4 different ports on it, and on the back it specifies that the ports are for different devices, so the 2 data lines are usually used to identify what type of charger it is, so that the phone or tablet or whatever knows how much current it can draw from it. So in the past I have noticed that this takes forever to charge my phone sometimes, so we can see what happens if we plug it into one of the ports on here. So if we choose A, which says for iPod and iPhone, if we plug that into there, so the charging rate on that's quite good, 0.98 amps. And then again we've got for Samsung, so if we plug that into B, and you can see here it's only charging at 0.44 amps, so that's probably a port that I've used before and noticed that the phone is quite slow at charging, so it's basically limiting it at 500 milliamps. If we try some of the other ports, it's a similar story here, so 0.44 amps and 0.98 amps. So you can see what they're trying to suggest that you use it for. It's just for checking whether your phone or whatever is charging at the correct rate. So that's all there is really to it. It's a fairly simple device. I'll see if I can take this apart and get the cover off, and then we can just have a quick look at the circuitry and see how they've got it to work. Right, so I think I've managed to crack the case open, so let's see if we can pull it apart and have a closer look at the PCB. So I'll just zoom in the camera and we'll have a closer look. So you can see it's quite a neat design. So they've just got one PCB with the USB ports connected directly to the board. We've got some, probably a processor there and a bit of regulation circuitry. We've got an OLED on the front here, which looks fairly similar to one that Midas Displays was showing to us at work a few months ago. So it's really quite a small OLED display, probably 128 pixels by 32 or something like that. On the rear, we've got the shunt resistor, so this is presumably in line with either ground or 5 volts, and then they're just measuring the voltage across this shunt resistor to get an idea of the current flowing through the USB port. And then we've got the tactile switch here, which is actuated by a little cutout in the plastics. So I'll see if I can just manage to prise the display. It seems to be glued at this end. That seems to be coming away. There we go. Okay, and I'll just stick the macro lens on the camera and we'll have a closer look. So here we have the main section of the PCB, and we've got an ST microcontroller here. So this is an STM8S003, which is an 8-bit microcontroller. It can run at 16 megahertz and it's got 8K of flash and 128 bytes of data EEPROM. And it also has a 10-bit ADC, which we'll be using to read the voltage from the USB port and the current which is flowing through that shunt resistor. And then we've got a voltage regulator here. And they need that because although this device can run at 5 volts, if you're using the quick charge technology, the voltage on the USB port can actually rise up to 12 volts, so they need a regulator here, and I think this is a 3.3 volt part. We've got some capacitors here for decoupling, a bulk storage capacitor here, 4 volt 220 mics, so this is running at 3.3 volts. And then we've got a few passives around here, and then just on the underneath the OLED here, we've got an LM358, which is just amplifying the voltage across this shunt resistor, so it can read the current flowing through it. And then we just got the tactile switch, and then the OLED on a bit of flex, which is just soldered directly onto the PCB. So it's a relatively straightforward design. It seems to be quite well built actually. The soldering quality and everything's perfectly fine, and the construction's quite good. And it seems to kind of do what it says. So that's the review of the DROK USB charger adapter. Thanks for watching.